All right, this is a bit of a tricky customer. So we're told that we've got a map here. This is, if you're looking at the Theta textbook, this is Theta mathematics, and we've got Rotorua. I'll put R here. That's Rotorua. And we're told that Topor, which is down here, and I'll just make it a bit smaller so it's possible to see the whole thing in the one diagram. Here we go. So this is Topor. And I'll just put T for Topor. Let's see, so this is going to be, it's got a series of right angles that's drawn here, so right angle triangle, sorry. So this is Rotorua, this is Topor, and we're told that this distance here is 20 kilometers. Topor's 20 kilometers west of Rotorua, and Whakatane is 82 kilometers east of Rotorua. So here is Whakatane up here. Use W for Whakatane. All right, we're also told it's 12 kilometers north of Rotorua. So that means we've got to find, by the way, the question's asking how far is it from Topor to Whakatane? And of course, we've got to find this distance here, and I'll use a dotted line here to try and represent the distance we're actually after. Fortunately, though, we can see this is in fact a right angle. This is a right angle. These are all right angles. So we can actually fast track this process by simply drawing in a line along here and continuing this line down here, creating ourselves a right angle. And let's use Pythagoras. This is, let's call this length here, the dotted line is A, and we of course know that A squared is equal to B squared plus C squared. We know that this distance here, we're told this is 62 kilometers, because the Topor is 62 kilometers south of Rotorua. So this means this is 62, and so the total distance here is 62 and 12, which is going to be 74. So let's call this distance here, let's call it B. This distance here is B, and I'm going to write here B equals 74. In other words, 12 plus 62. Now this distance here, I want to call this C. And C is going to be 82. See, this is 82, this bit here. Plus the 20 is going to be 102. So 102. And these are kilometers. I'm not going to put the units in at this stage. We'll worry about the units till the very last moment. Okay. So now we can go ahead and use Pythag and see how far what distance that line is. So we can go A squared is equal to B squared plus C squared. I'm going to restate it. So A squared is equal to, so we've got B squared, which is 74 squared, plus C squared, which was the 102 squared. Sorry, you can't see that. Keep doing that. I'm so sorry. All right, so this all comes to, I'm going to say A now equals root. Well, 74 squared, it's going to be 54 plus 102. Well, that's not too bad. That's 104.04. That should be right. Okay. So adding those two together, we end up with what's that? 15,880. All right. So the square root of that. Now I'm going to have to use a calculator for this bit. Square root 15,880. Square root of the answer there is 126. So equals 126.0, by the way. So I was going to say 126 kilometers, and it asks for the nearest kilometer, and so that would be the answer we're looking for. So that's all we needed to do, really. We just had to realize that because these were right angles here, and we could extend this along here and draw a right angle here, then this was just going to be the hypotenuse of this slightly larger triangle across here. And that's the way which I would approach solving 102 question 4. You could, of course, give these values as in coordinates, but really you don't need to. You can call that 0, 0 if you wanted, and therefore this would be also 102 along. So if you call that 0, 0, for example, then this would be 102, comma 74. So lots of different ways you could go ahead and do that, but it's just simply a matter of counting the squares and then feeding that into the coordinate geometry distance formula. So whichever way works, but I would personally just use that Pythagoras equation. It gets you there pretty quickly.